Hi, today we're going to be talking about one of the classes of biological molecules based on carbon, and that is carbohydrates. Specifically, we're going to be talking about monosaccharides and disaccharides. Now, if you have a good understanding of these, then go ahead, fast forward to the end where we'll be talking about ways to tell carbohydrates from the other classes of biological molecules, and there'll be some practice questions to make sure you understand monosaccharides and disaccharides. Now, carbohydrates are the most abundant biological molecules on Earth. Now, carbohydrates contain carbon, hydrogen, and oxygen. And in the smallest carbohydrates, which are the monosaccharides, for every one carbon, there's going to be 2 hydrogens and 1 oxygen. Okay, so if there's 6 carbon atoms, there's going to be 12 hydrogens and 6 oxygen molecules in those monosaccharides. So you also can kind of view it like this. For every C, there's going to be 2 hydrogens or H's and 1 oxygen. And now you can kind of see why we call these carbohydrates, right? Carbo is like carbon, and hydrate, well, if you hydrate yourself, what do? You add water, right? So carbohydrates have water, H2O, and carbon. And in those monosaccharides, this is the key. For every 1 carbon, there's 2 hydrogen atoms and 1 oxygen atom. Now, as far as carbohydrates go, we're going to be talking about the smallest carbohydrates, the monosaccharides and the disaccharides. And I'm going to break down what they are and what that means. Now, the monosaccharides are the smallest carbohydrate molecules, okay? And they're called monosaccharides. The word saccharide is derived from a Greek root that means sugar or sweetness, because the monosaccharides and the disaccharides, those are sweet when you taste them. They're sugars. Okay, so monosaccharides are essentially one sweetness unit. Okay, they're one molecule. They're the smallest of the carbohydrates. And so here's an example of a monosaccharide. This is glucose. Now, 2 monosaccharides can link together to form a disaccharide. So disaccharides are a little bit bigger because instead of just having 1 structural sugar there, they have 2 that are bonded together. And you can kind of see that when you look at the structure of these molecules. Okay, so don't get lost in all of the structure of these molecules that we're looking at. Just really look at the fact that monosaccharides are made up of 1 structure. That's a sugar, 1. And disaccharides, well, di means 2. So when 2 monosaccharides bond together, that forms another sugar known as a disaccharide. And it's about twice as big as the monosaccharides. Now, in a different video, you can learn about polysaccharides. Okay, so thousands or hundreds of monosaccharides can be bonded together in these long chains, right, that are called polysaccharides. Poly means many, right? So many monosaccharides get bonded together into polysaccharides. And examples of polysaccharides are no longer sweet because they're bonded together into a different structure. So examples of polysaccharides are things like starch or glycogen or cellulose. But today we're going to be talking about the monosaccharides and the disaccharides. Let's hit on the monosaccharides first. So the monosaccharides are the smallest carbohydrates, and they are sugars. Remember, saccharide means sweet. So mono means 1, saccharum means sugar. So these are made up of 1 sugar. And they usually contain between 3 and 7 carbon atoms. They are water soluble, and that means they dissolve in water. And you know this, right? If you take some sugar and you stir it into water, it actually will dissolve into that water. And here's the structure of 3 common monosaccharides, namely erythrose, ribose, and mannose. And don't get caught up in, memorizing the structures of these. I want you to look at them sort of from afar. Now, what you'll notice is that they can have different number of carbons. So erythrose has 4 carbons, ribose has 5, mannose has 6 carbons, okay? So the monosaccharides generally have between 3 and 7 carbon molecules. Now, also keep in mind that we see what else here? We see hydrogens and oxygens, and we see them at that ratio, right? Because with monosaccharides, for every carbon, there's going to be 2 hydrogens and 1 oxygen molecule. So in erythrose, there's 4 carbons. That means 8 hydrogens and 4 oxygen molecules. Now, these are all in a line, right? The structure of the carbons is all linear. We call these linear monosaccharides because their structure is linear in a line. And what I want you to notice is that over at the top of the structure, we see this carbon that shares a double bond with oxygen. Maybe you'll recognize that as a carbonyl group. Okay, so when we have that carbonyl group and the other carbon is bound to a hydrogen, we call that an aldehyde. Okay, so these are all known as aldehyde sugars, okay, or aldoses. And you might recognize erythros, ribose, and mannose all end in OSE, ose. That's a clue that we're talking about a sugar, okay, because sugars end in ose. Now, there's these OHs, these hydroxyl groups that you find off of the carbon in these sugars. The OHs, depending upon the sugar, they can be on the left side, they can be all on the right side, they can be mixed between the left and the right side of the molecule. And that defines different sugar structures, okay? But remember, the monosaccharides, the smallest of the sugars, are going to have that 1 to 2 to 1 ratio of carbon, hydrogen, and oxygen. That's a way to tell that we're talking about a monosaccharide, which generally has between 3 and 7 carbons. Now, monosaccharides that have 5 or more carbons can often form ring structures. So here we have the linear form of glucose, and glucose is a very important monosaccharide, very important sugar in our bodies. It has 6 carbons, 12 hydrogens, and 6 oxygens. Now, what can happen is that the linear form can actually create a ring structure so that the carbon that's found at this first carbon in the 6-carbon chain, right? This carbon can react with this hydroxyl group, this OH that's found next to the 5th carbon. And so when that happens, it actually forms a ring. So here's the structure of glucose as a ring. And those monosaccharides with at least 5 carbons can form these ring structures frequently. So monosaccharides are the smallest of the carbohydrates, and they can form linear sugars, or they can form sugars with a ring structure, like we saw with glucose. Now, 2 monosaccharides bonded together are known as a disaccharide. So you can almost see it when you look at the structure, right? We've got 2 rings here. We have 2 monosaccharides that bonded together. So here's how monosaccharides bond together to form disaccharides. And the reaction is going to take place with these hydroxyl group, these OHs that are found on the structure of glucose. Now, within those OHs, we find that there is H2O, right? So within 2 hydroxyl groups, we have 2 oxygens and 2 hydrogens. Well, what's going to happen that as these 2 glucose molecules react with each other to form the disaccharide, 1 water molecule is going to be lost, okay? So we see here that as they bond together, we see that 1 water molecule is going to leave that structure. This is known as, by the way, a dehydration reaction, okay? So when molecules react with each other, and water is released as part of the reaction, we call that a dehydration reaction. And the way that I remember this is, well, if you're dehydrated, it means you don't have enough water, right? You've lost water. And that's what happens in a dehydration reaction, that as the reactants react to form the products, water is one of the products. So here we have glucose and glucose, these 2 monosaccharides react to form maltose. And in the process, 1 water molecule is given off. See how that works? And now we can clearly see maltose is a different structure than the individual glucose molecules because it's lost 2 hydrogens and 1 oxygen. And it is a disaccharide, okay? So it's made up of 2 monosaccharides that are bonded together. Now, in case you need to know, we call that linkage, right? The bond that happens between those 2 monosaccharides to form a disaccharide, we call that a glycosidic linkage or a glycosidic bond. And you might see something like 1,4 glycosidic linkage. Well, that just means that the first carbon of 1 molecule bonds with the 4th carbon of the other molecule. We have two molecules of glucose, and where they bond together, where that reaction happens, is on the first carbon of one glucose and the fourth of the other. So that's a glycosidic linkage, and more specifically, it's a 1,4, because those are the numbered carbons that react to form this particular disaccharide, which is maltose. Now, keep in mind that the monosaccharides, like glucose, are going to have, for every one carbon, they're going to have two hydrogens and one oxygen. It's going to be similar for the disaccharides, but remember, in the process of joining together into the disaccharide, one water molecule was released, right? So if you see a chemical equation, right, that has carbon, hydrogen, and oxygen at a 1 to 2 to 1 ratio, except there are 2 fewer hydrogens and 1 fewer oxygen, then you're probably looking at a disaccharide. So glucose is C6H12O6. Now, the disaccharide maltose should be twice that, right? C12H24O12, but you have to remove 2 hydrogens and an oxygen from that, right? So it's C12H22 instead of 24 hydrogens, and then O12 minus that oxygen from H2O, so that we have C12H22O11. So these are just hints that you can use to try to figure out when you're looking at a chemical formula, if you're looking at a monosaccharide or a disaccharide. But remember, both of these are sugars, both of them are sweet, and they have carbon, hydrogen, and oxygen within them. Here's another example, okay? If we have the monosaccharide glucose bond to the monosaccharide fructose, a dehydration reaction occurs, and we end up with the disaccharide sucrose. Now, in this case, it's the first carbon of glucose and the second carbon of fructose that end up being where that bond with oxygen is found in sucrose, so that is a 1,2 glycosidic linkage. Do you see how this works? So monosaccharides are the smallest of the carbohydrates, and 2 monosaccharides bond together to form disaccharides. Both of these are sugars, and both of them are sweet to the taste. So let's look at some monosaccharides that form disaccharides. Now, we just saw that 2 glucose molecules can combine together to form maltose. Have you heard of maltose? Maybe you've heard of like malt milkshake or malt balls, right? Well, maltose is a sugar that's found in germinating seeds, and it is a major sugar used in the brewing industry. So if you've heard of malt being part of beer, well, that's maltose they're talking about. Okay, malt is a cereal grain that's been dried in a way to break down the carbohydrates into sugars like maltose. Let's look at another one. Glucose and fructose bonded together form the disaccharide sucrose. Do you know what sucrose is? Sucrose is table sugar. So if you put sugar on your cereal, you're putting sucrose on your cereal. Sucrose is the most plentiful sugar in nature. It's made in different parts of leafy plants. Okay, and the table sugar is made from extracting and crystallizing sucrose from those plants, such as sugarcane. Here's another example. Glucose and the monosaccharide galactose can combine together to form the disaccharide lactose. Have you heard of lactose? Lactose is the primary sugar in milk. Okay, so if you're lactose intolerant, you actually lack an enzyme, lactase, that breaks down lactose in your stomach. And so if you can't break down lactose, well, lactose can continue on in your digestive system and be broken down by bacteria there and can cause things like gas and bloating. Okay, so lactose is the primary sugar of milk. Now, what do we notice with all of these, right? We notice they all end in OSE because the sugar carbohydrates end in OSE. That's a hint that it's a sugar. So let's put together all of these clues for identifying those carbohydrate sugars, namely monosaccharides and disaccharides. Now, first off, remember that both monosaccharides and disaccharides contain carbon, hydrogen, and oxygen. If it's a monosaccharide, the ratio is going to be 1 to 2 to 1, like glucose, right? C6H12O6. If it's a disaccharide, well, there's going to be more carbons, and the ratio is 1 to 2 to 1 minus H2O, 2 hydrogens and oxygen, because an oxygen molecule was released in the joining of those two monosaccharides into a disaccharide. So in this case, instead of C6H12O6, if we have two glucose molecules that bond together to form maltose, then we have C12H22, not 24, right? Because it's times 2 minus 2, right? So C12H22 and O11, because an oxygen molecule was also released in water during that reaction. The second hint that it's a monosaccharide or a disaccharide is that the name of it ends in OSE, ose, right? Lactose, sucrose, fructose, galactose, maltose. Ose indicates it's a sugar, meaning it's a monosaccharide or a disaccharide. Another thing to watch out for is that monosaccharides can be linear or ring-shaped. So here's an example of a linear monosaccharide. This is ribose, which has 5 carbons in it, because remember, monosaccharides are going to have between 3 and 7 carbon atoms in their structure. And maybe you remember ribose because it's found in ribonucleic acid. That's what the ribose stands for, ribose. Ribonucleic acid, that's RNA, right? And the nucleotides of RNA have the sugar ribose in them. Now, we know that monosaccharides, like ribose or glucose, can also be ring-shaped, right? They can form ring structures like this here, this picture of glucose. Now, remember, disaccharides are composed of 2 ring structures. So when you look at their structure, you can sort of see what used to be those monosaccharides that have now bonded together into the disaccharide. So keeping those things in mind, let's try this practice question. Which of the following is a monosaccharide? Now pause the video, see if you can reason through and answer the question, and then come back, we'll answer it together. Okay, which of the following is a monosaccharide? Glycerol, galactose, lactose, or serenate? Okay, pause the video, see if you can answer it, and then come back, we'll talk about it together. Okay, so this question asks, which of the following is a monosaccharide? Now we know that monosaccharides are carbohydrates that contain carbon, hydrogen, and oxygen. If we look at all of these, we see that glycerol, galactose, and lactose have carbon, hydrogen, and oxygen. Serenade does as well, but it also has nitrogen. That's what the N is for. Okay, so we can cross out serenate because monosaccharides and disaccharides only have carbon, hydrogen, and oxygen in them. Now we know that monosaccharides have between usually 3 and 7 carbons. So when we look at how many carbons are found in glycerol, galactose, and lactose, we can see that lactose has 12 carbons in it. C12H22O11. Okay, so that's more carbons than you would find in a monosaccharide. And you might remember lactose is a disaccharide, right? So we can cross out lactose. It has too many carbons to be a monosaccharide. So now we're left with glycerol and galactose. And we need to think, well, for monosaccharides, remember that 1 to 2 to 1 ratio. For every carbon, there's going to be 2 hydrogens and 1 oxygen. So now let's look. Okay, glycerol has 3 carbons. If it were a monosaccharide, it would have twice as many hydrogens. But this one, instead of having 6 hydrogens, has 8. Okay, so even though it has the same ratio of carbons to oxygen, 3 to 3 or 1 to 1, it has too many hydrogens. It would be C3H6O3 if it were a monosaccharide. So we can rule glycerol out, but let's make sure that galactose follows all these rules. It ends in OSE, so we know it's a monosaccharide or a disaccharide. It has 6 carbons, and it follows that 1 to 2 to 1 ratio because there's 6 carbons, twice as many hydrogens, 12, and 6 oxygen molecules. So the answer here, which of the following is a monosaccharide? It's galactose. Let's look at another question. So here we have the same potential answers: glycerol, galactose, lactose, and serenate. Which of the following is a disaccharide? Now pause the video, try to figure out how you would reason an answer considering what we learned, and come back, we'll go over it together. Okay, which of the following is a disaccharide? Now we can use what we learned in the first question about a monosaccharide to rule some of these out, right? Serenate has a nitrogen in it. And we know that mono and disaccharides are just going to have carbon, hydrogen, and oxygen in them. So we can rule out serenate as well. We know that galactose is a monosaccharide, so we can rule that one out. That was the answer to the previous question. So now we're left with glycerol and lactose. Now, disaccharides are going to have essentially two monosaccharides bonded together. Now, in this case, glycerol with only 3 carbons, well, that's too small to be a disaccharide. So lactose is likely our disaccharide here. And we can check, right? Because lactose has that 1 to 2 to 1 ratio of carbon to hydrogen to oxygen, but we have to remove an H2O from that chemical formula. In other words, we have to remove 2 hydrogens and 1 oxygen. So here's lactose with 12 carbons, 22 hydrogens, and 11 oxygen atoms. So that follows the disaccharide, right? It's that 1 to 2 to 1 ratio of carbon to hydrogen to oxygen minus the 2 hydrogens and the 1 oxygen atom found in the water molecule that's released when the monosaccharides bond into that disaccharide. So the answer here is lactose. Lactose is our disaccharide. Now, let's look at this question. Same answers: glycerol, galactose, lactose, and serenate. Which of the following are sugars? Pause the video, see if you have an answer, and then come back. We'll talk about it together. Okay, sugars. What do we have to know here? Well, sugars are monosaccharides and disaccharides. They literally are sweet when you taste them. And remember this, right? Because we know things like glucose are going to be sweet, but sucrose, that's table sugar, well, that's also sweet. That's a disaccharide, right? So when we look here at this question, we want to identify, well, which are the mono and which are the disaccharides? And from our previous questions, we know that galactose is a monosaccharide and lactose is a disaccharide. So the answer here is that number 2 and number 3, galactose and lactose, those are our sugars. So if we were given this question and we didn't have the previous questions to help walk us through it, which of the following are sugars? Well, we have to be able to identify any monosaccharides or any disaccharides. We can do that by looking at the names of these substances because we know that sugars are going to end in OSE, right? Like galactose, lactose, glucose, right? That's a hint that it's a mono or a disaccharide. We also can follow up and make sure, well, monosaccharides are going to have that 1 to 2 to 1 ratio of carbon to hydrogen to oxygen. Disaccharides also have carbon, hydrogen, and oxygen, and it's similar to that 1 to 2 to 1 ratio, except that it lacks a water molecule, 2 hydrogens and an oxygen. So we could also look through this list and find that galactose and lactose fit the bill on those clues. And by the way, if you found this video to be helpful, please do subscribe to my page. And that way YouTube's algorithms will be more likely to select my video to show it to other people who are looking to learn about monosaccharides and disaccharides. Okay, so today we learned about monosaccharides and disaccharides. These are the smallest of the carbohydrates, right? Monosaccharides are one structure, and disaccharides are essentially 2 monosaccharides bonded together. Now, monosaccharides can also be bonded together in long chains of hundreds of monosaccharides to form polysaccharides. Poly means many. So mono means 1, di means 2. Polysaccharides mean many. So many monosaccharides become bonded together to form polysaccharides, which are these large carbohydrates that are formed by joining lots of monosaccharides together. So examples of polysaccharides include things like starch, glycogen, cellulose, or chitin. They also have carbon, hydrogen, and oxygen, but sometimes they can have other atoms in them as well, like nitrogen, depending upon the polysaccharide. So we'll talk about that in a different video. Today, I hope you now have a good understanding of monosaccharides and disaccharides, what they are, and how to distinguish them from other structures.